My name is Phyllis Tierman, and I am on the Sustainable Wellesley Leadership Team with Mary Gard and others who are on the call this evening. Welcome, and thank you so much for joining us. Tonight, we're talking about how to heat your home more efficiently and more comfortably. And I'm going to share my screen for a second, if I can pull this off one moment. Presentation mode. So this is the event that we have tonight, and many of you are here because you want to, heat your home more comfortably, and efficiently for the planet and more economically. But I also want you to consider that what we're burning to heat our homes is really what we're inhaling and what we're breathing. So just keep that in mind. This is also a health issue. And for those of you that, don't know, Wellesley's working on its climate action plan. It's pretty much nearly complete. But before they did the plan, they did an inventory of where most of our greenhouse gas emissions come from. And this, you can see that 50% of our emissions come from buildings, so more than half. So when you're thinking about ways you can, do something for the planet, you're in the right place. Buildings is really the biggest chunk. And of the buildings in our community, 58% of them are residents. So this is a really great opportunity to make that pie chart look different. So thanks for being here. And the good news is that the light plant has extended what they call the Clean Comfort Program, which offers some financial rebates and some unbiased and some expert advice on how to move to mini splits and air pumps and things like that. So I'm sitting here, I usually don't sit here, but tonight I'm sitting here so you can see mine, which is in use. Which is there, but is not in use because I am going to learn something tonight. And I usually turn on in the extreme moments when it's really hot or really cold, and as Chris will tell you, that's not the right way to do it. So I'd like to welcome Chris. He is from Abode Energy Management. They've been hired by the light plant, and he's going to give his presentation, and then we're going to follow up and talk to some folks, some of our neighbors and friends in town who also have some installed, and talk about their experiences. So I'm going to stop sharing, and I'll give Chris the opportunity to present. Give me 1 second to figure out how to do this here. Stop share. There we go. Chris, it's all you.
All right, thank you. Can everybody see that? Good. All right, so yeah, my name is Christopher Herringa. I'm the program manager here at Abode. I oversee our municipal light plant heat pump programs. So thanks for having me. Glad to be here. And tonight we're gonna chat about heat pumps. So just to start things off, what is a heat pump? How does it work? So it's a versatile, efficient cooling and heating system. It operates using electricity. So heat pumps do not burn any fuel. They just move heat from one place to another. So to provide heat, a heat pump works by extracting heat from the air outside of your home and transferring it to a refrigerant. And it can do that even when it's incredibly cold outside. The refrigerant is then compressed, which increases the temperature significantly. So then that hot refrigerant is then moved to the indoor unit of the heat pump, which then passes air over the hot refrigerant and transfers it to the air. So when in cooling mode, a heat pump and an air conditioner are functionally identical, so absorbing heat from the indoor air and releasing it through the outdoor unit. So when in cooling mode, the refrigerant moving to the indoor unit of the heat pump is very cold, and then that's how it transfers cool air to the space. So looking at heat pumps and operating, so many of you know that they're clean heating technology. So looking into the more details here, this chart examines how many tons of CO2 emissions heat pumps versus traditional heating systems create over the course of 20 years. So including emissions from the fuel, heat pumps have the lowest emissions. And you might think that heat pump operating emissions are indirect, you could say, so they don't burn anything at the source, so there's no direct emissions from the operation of the unit itself, whereas fossil fuel systems burn fuel at the unit and have direct emissions from operation. And so this chart is using New England's electricity generation mix to calculate emissions for heat pumps. The cleaner the electricity is produced, the cleaner the air source heat pumps will become. So for instance, if you're purchasing solely renewable energy, or if you had enough solar and backup batteries at your house, your operating emissions would be zero. WMLP's electricity generation mix is even cleaner than the representation above, so operating a heat pump in WMLP's service area will have even lower emissions. Plus, another nice thing about being a customer of a muni light plant like WMLP is that they have the opportunity to be more progressive and expedite the adoption of cleaner energy versus larger entities out there. So a few key points here: energy production is getting cleaner every year, which means heat pumps' carbon emissions are reduced year after year as well. And already heat pumps over the lifetime of operation have the lowest emissions. And so for those of you listening who have traditional heating systems as well as heat pumps and sometimes swap over to the traditional heating system during the winter, this slide is particularly important for you. So this chart looks at 10 years of heating season data in Massachusetts. The x-axis is temperature and the y-axis is the amount of hours spent at that temperature. As we can see in the chart, we spend a lot of time during the heating season at warmer temperatures. In fact, we spend about 70 to 80% of our heating season at 32 degrees and above. So as you may know, heat pumps cost less to operate the warmer the outdoor temperature is. So you definitely want to be using your heat pump to take advantage of those savings. At the same time, we do spend 20 to 30% of our time below 32 degrees, but that's really no sweat for a heat pump. Modern heat pumps are still incredibly efficient below freezing and continue to operate even well below zero. And this chart is using the same 10 years of heating season weather data as the previous chart, but it's looking at it in terms of operating cost in order to compare different fuel types. So the chart is using WMLP's price per kilowatt hour to represent the cost to heat with electric resistance or with heat pumps. And so that's using 14.6 cents a kilowatt hour. As you can see, air source heat pumps with municipal light plant electric rates are extremely cost competitive. So heat pumps can effectively beat all of their fuel types regardless of the outdoor temperatures. There is an exception there though with natural gas, which may not be the case for long given the forecast on natural gas prices. However, at lower outdoor temperatures getting below freezing, heat pump and natural gas operating costs are more in line. And then with operating costs in mind, it really makes sense just to run your heat pump as your primary source of heat as much as is possible with your system. So kind of looking into some of the details about the product. So there's single zone or one-to-one units. They're incredibly efficient at both heating and cooling. The outdoor condenser can connect to a ductless unit as shown, or it could connect to a ducted unit. And depending on the size of the outdoor condenser and the type of the indoor unit, you can condition a very small room to a large great room, for instance. And then multi-zone, or 1 to 3 as shown in the image, can also be connected to ductless, ducted, or a combination of indoor unit types. Still providing excellent efficiency when heating or cooling, these units can handle multiple rooms or floors or a whole house depending on how they are configured. So while one multi-zone unit could be configured to have enough indoor units to provide a solution for the whole home, manufacturers encourage best practice designs that break up the responsibility to multiple outdoor condensers rather than one. And this can increase efficiency, your control over different areas of the house, your comfort. It reduces the risk of any performance issues. It also adds redundancy if one of the systems were to go down. So ductless units, they're versatile enough that you can size them to heat and cool large open areas, like we said, or even small bedrooms or offices. There's a lot of form factors when it comes to the ductless system. So starting with the wall hung unit on the left that most of us are familiar with, this can easily be hung on exterior walls and sometimes interior walls, depending on the situation. You can get a floor mount unit that looks a little bit more like a floor radiator, at least in where it is located. These are becoming increasingly popular and are a great alternative to the wall hung units. And then there are ceiling cassettes. Those can be mounted into your ceiling. The bottom picture in the ceiling cassettes category is a bit of a newer product that does a better job of fitting between the joists in the ceiling, which is previously an issue in terms of fitting some of the other ceiling cassettes, those square ones you could see in the image. So again, there are new technologies coming out all the time, making this technology very practical to install. We're also seeing more and more ducted systems, mini ducts or compact ducts. So we've got a lot of different names, but essentially the mini and compact ducted units can be set up with some amount of short run slim ductwork that allows you to use one unit and impact a few different smaller rooms. So these can be really handy to use in parts of the home where the bedrooms and bath are located. So that each room doesn't require a ductless unit on the wall there. So these units are growing in popularity. The industry might be a little more comfortable with centrally ducted units, but we're here to help you find the right contractor if one of those makes sense for your home. And these units can range from the low static pressure product on the left that can probably only serve 1 or 2 rooms to a medium static pressure product that can serve a whole floor or like 3 to 4 rooms. And then finally on the right, a more traditional high static pressure centrally ducted product that can serve a whole house. You can see here there's a lot of variety on the design side that you can leverage to find a solution that makes sense for your home, both functionally and aesthetically. And you can mix and match what you have in your house. So a design that might be a good idea for some folks is to utilize a compact ducted unit for the bedrooms, bath, hallway part of the house. And you could see about using a ductless unit to serve some of that more open living area of the home. So we'll take a look at sound while we're here today too. So first, to kind of explain a little bit about sound. So A-weighted decibels, or dBA, are often used when describing sound level recommendations for like healthy listening. So while the decibel or dB scale is based only on sound intensity, dBA scale is based on intensity and how the human ear responds. So because of this, dBA gives us a better idea of when sound could, for instance, like damage your hearing. Then there's loudness. So as in how loud we experience something being. That's on a different scale where moving up 10 decibels from a given level, it'll be perceived as twice as loud to us. The opposite, if we move down 10 decibels, it is experienced as half as loud. So from 70 to 90 decibels, we're experiencing something that would be 4 times as loud. And from 70 to 50, it would be 1/4 as loud. So as we all know, when you're farther away from something, it's not as loud. This is because of something called the inverse square law, where every doubling of distance from the source of a given sound, it's reduced by 6 decibels. So if you were 10 feet away from something and you were experiencing 56 decibels, and then you moved to 20 feet away, it would be 50 decibels, and so on as you continue to double your distance away from your original position. So I'm sure many of us here are familiar with noisy old window ACs or old central AC systems rattling away. Old cooling technology was noisy, no doubt, but modern heat pumps are actually incredibly quiet. So I want to take a look at that on the chart here. So you can see the indoor units, they're typically ranging between 20 to the upper 30 decibels. And then you have your outdoor units. Those are typically at the low end 40 and at the high end closer to 60. But that's going to put us, between like rustling of leaves and whisper on the inside of your house, and on the outside of the house, like a refrigerator or some rain or maybe normal conversation. The entry level, central AC systems that maybe still are out there, or the older equipment, that's a bit louder. It's going to be more in that 70 decibel range. So looking at popular mini split equipment, so looking at the outdoor units, here we can see the dBA of a number of popular brands of the ductless mini splits. So these dBA ratings there for their outdoor equipment, like the one on the right. So I included single zone and multi-zone units for comparison, and you can see how they are all relatively similar. The low end is about 45 dBA and the high end about 58 dBA. So that puts us between like your refrigerator, a normal conversation, things in that range. So for example, the highest rating seen here of 58 dBA. And remember, if the unit is running at maximum speed, that's the sound level it's going to be at. And with heat pumps, they're not always running at maximum speed. They're varying their speeds. So sometimes it's quieter, sometimes it's in the middle. When it has to work really hard because it's really cold or really hot outside, then it might be up towards 58. So if you were 1 foot away from the outdoor unit experiencing 58 decibels, 20 feet away from that position, you would experience about 32 decibels. 32 decibels is about the same as a whisper. I personally experienced this the other day when I was Out in Rockport, there was a unit just like this running outside a restaurant, and I heard it. And it was familiar to me, right? So I was like, where is it? I know it's around here somewhere. And I eventually found it. It was actually kind of hard to detect where it was. And I pointed at my fiance. I'm like, you hear that? She's like, hear what? I don't hear anything. I'm like, listen, do you hear that? And she still didn't hear it. So I had to point at the unit and say, look, it's running over there. Do you hear that? She's like, oh, now I actually notice. I can actually hear this thing. And that's how quiet they are. You won't even notice them just being in a regular area. So now looking at unitary equipment. So this is more the traditional style looking condensers outside. There are a lot of brands of heat pumps that have equipment that looks like this too. So the loudest heat pump here is rated at 79 dBA when it's operating at its maximum capacity. So remember, that doesn't always happen all the time. So again, using the inverse square law we described earlier and seeing how loud it would be. So let's say I'm standing right next to the unit in my yard at my house, and someone else is standing 40 feet away in their yard. So I'll be experiencing the sound around 79 dBA, which is about as loud as a window AC. The other individual 40 feet away will experience 40 dBA. So 40 dBA is comparable to like being in a library or your refrigerator. So it's approximately 1/8 as loud when standing 40 feet away. So let's say you were only 20 feet away, half the distance, increasing the decibels by 6. Again, that's comparable to conversation, like a babbling brook, your computer running, things like that. Your own dishwasher running in the next room could be louder than that. So if we use something of an average here between these heat pumps, say like 60 decibels, 20 feet away, that's somewhere between a whisper and the rustling of leaves. So now that we have a good picture of just how quiet these units actually are, let's compare it to some other outdoor equipment you maybe see in your neighborhood from time to time. So a quiet lawnmower, that can be around 80 decibels. Typical leaf blower can be up to 90. Some weed whackers can be up to 100 decibels. So from our average of about 60 decibels, a lawnmower is 4 times as loud as a heat pump, leaf blower 8 times as loud, and a weed whacker potentially 16 times as loud. So the rebates. These are the rebates that Wellesley Municipal Light Plant offers. So for your central heat pumps, your multi-zone heat pumps, or your ducted mini split equipment, they have a slightly lower efficiency requirement. These efficiency requirements still allow a wide range of equipment to be accessible to the program, but still requires the equipment to be considered high efficiency. And then for your single zone mini split ductless units, they have slightly higher efficiency requirements. Those are for the most part very easily achievable for a lot of that single zone ductless equipment because it's just so efficient. They offer $500 per ton up to $2,000. And so 1 ton is 12,000 BTU. So they base the rebate off of the unit's rated cooling capacity. So if it's a 24,000 BTU unit, that would be $1,000 in rebates. So the best way to get help through the no-cost conversations the best way to get help about heat pumps would be through the no-cost conversations that you can get through WMLP offered by Abode. And so what we're doing there is we just want to understand your goals, your motivations, and your home to give you information and resources you need to make a decision that's right for you and your family. So through those consultations, we're really happy to cover whatever your needs are, whether that's a general conversation about heat pumps and what they are, how they work, or if you want some support evaluating multiple bids, we're here to help. At the end of the day, we want you to be prepared to move forward with heat pumps with a contractor of your choosing, if it makes sense. WMLP strongly recommends scheduling a home energy assessment as well. And so if you have natural gas heating, you would schedule with Mass Save. And if you have another fuel type for heating, you would schedule with Energy New England. Energy assessments are an important part of considering the house as a system. So these assessments provide you with the opportunity to learn more about your home, the opportunities to increase efficiency and comfort through things like insulation and reducing air infiltration by kind of buttoning the house up a bit. So the weatherization of your home is an important part of adopting heat pumps. So as part of the program, Abode does curate a participating contractor list. So there are lots of contractors in the community. Despite our best efforts, they may not be on the list, but we're here to engage with them and explain how to file for rebates. So With this list, we're not directly endorsing any contractors, but contractors on this list have passed an application process. So we check to make sure they've attended relevant manufacturer training for the equipment that they install. We've checked references on their work, their licenses, insurance, and they've committed to provide a high quality customer service to operate in the program. And they're also familiar with the pre-approval and install QA steps of the rebate process. So just so you know, customers are not required to use the contractors on the participating list. As long as the pre-approval and install QA steps are followed by our contractor, you can absolutely still receive a rebate. Contractors on our list are already familiar with that process, so that's nice. So let's take a look at those steps. In order to receive a rebate, your contractor must submit a pre-approval form prior to installation and an install quality assurance form after install is complete. So the pre-approval form is where the contractor submits information about the home and the system that's planned to be installed. So when we receive the pre-approval form from the contractor, we'll consider, is the equipment reasonably sized for the space being conditioned, the type of floor plan, and the building envelope? Is the equipment selected appropriate for that type of floor plan and the intended use? And are we optimizing the runtime and use of that equipment? And then install happens after the approval is given. And then after that, the contractor should fill out the install QA form. So the install QA, or quality assurance, is used to ensure systems meet best practice installation guidelines for cold climate air source heat pumps. So they're providing key photos of installed equipment and the site conditions, and they're responding to attestation questions regarding the steps of the install. And once we receive that and approve it and send everything over to Wellesley, the customers are going to receive a survey. And so the surveys are used to ensure participating contractors are continuing to provide great customer experiences. And so we strongly encourage folks to fill those out. At that point as well, the customer can fill out the online rebate application. Or it's a fillable PDF in the case of Wellesley. And then you can send that over back to us. So once we receive the install QA form and your rebate application from you and your contractor, we'll send everything over to WMLP on your behalf. So this slide details Abode's quality assurance process that we do for you. However, there may be other town requirements such as permits or a wiring inspection or plot plans that need to be completed in order to receive a rebate. So we're happy to point you in the right direction if you need help on any of those matters. We do not oversee that process ourselves. All right, so if you're thinking about adopting heat pumps at your home, you can feel free to schedule a consultation with Abode. And you can use that QR code on the left, and that'll bring you to our scheduling tool. And then in addition, I encourage you to check out NEEP's Consumer Air Source Heat Pump Buying Guide, and you can use the QR code on the right for that. That's a really handy guide. It provides lots of good fundamental information about heat pumps, information about things if you're considering ductless or if you're considering a ducted system, and the important stuff that you should be thinking about when designing a system that might be one of those two types. And then actually has a whole page of good questions to ask contractors and a 5-step process to get good quotes and get a good install. So really, really good guide to have around. So thanks for listening. I hope you enjoyed that. And I'll pass it back to Phyllis if we want to start a QA or whatever you'd like to do next.
Thank you, Chris. So he was our expert, which that's what he is. And now we have some folks from our community. So I am going to take over the screen share. And Monir, since if you wouldn't mind, I'm going to put you up first. And I'm going to show your slides. One moment.
Oh, okay. I'll go.
You can start chatting.
I can go through them very quickly anyway.
Okay.
So the heat pump system that we put in our house is really part of a phased adventure to really try and do everything we can to zero out our carbon footprint. And that's the picture of the house. And actually, we're the first house to have photovoltaics. The PV installation that you see on the right, and that's actually south facing, was installed in 1998. So they've we've gotten more than 20 years out of it. And those solar panels are getting, they are starting to see end of life. If you look at the roof that's above that, there's actually a solar thermal system up there. And then on the west roof, on the front of the house, you see the PV system that we just installed in December of last year. So grand total, there's about almost 8 kilowatts on the house. And the idea was, very much to what Phyllis said at the start, was really to do everything we can to get out, get away from natural gas burning consumption inside the house. Even though when we first got it, we converted from electric to gas stove, we're now back to a beautiful induction convection stove. Induction stovetop and convection oven. So the heat pump system, and Phyllis, you can connect it, go to the next slide, is sort of integral. It's sort of, really a very simple installation that was dedicated only to the first floor of the house, because we did a renovation on the first floor this year. Roughly speaking, it's probably around 1,600 square feet, and it's a 18,000 BTU system with 2 mini splits from LG. I would say the installation and the operation are really as advertised, very quiet. We did a couple of things that if you go to the next slide. Oh, I should point out how this is set up. So you can go to the next slide. Go ahead. It's perfect. And here's one point where I can state one of my frustrations with the program in the town. You can see on this plot plan, and what we did here is, can you actually see my mouse? No, you can't, I would say.
Can you see mine?
Yeah, anyway, so the heat pump is sort of in that nook of the house that is well within the setback rules of the town, and in that case, that was one of the biggest challenges of the whole thing, was actually getting the plot plan, which cost $1,800. In which it's pretty clear to tell that there's no way that location could violate any of the setbacks, but still we had to go through that expense. And then in this case, the mini splits were put on the what would be the east walls.
Sorry.
Yep, no, what we did is we did keep the gas furnace. We ripped out the radiators on the east side and really the south side, and actually just put in some new radiators on the west side, just in case. But so far, and it hasn't gotten that cold. Those have not come on. It hasn't called for any heat there, and we did set the temperature lower, and I'm sure Chris can address some of the best strategies there. So that's how we set it up. And then you can go to the next slide, Phyllis. And this just shows unfortunately, this is not great, but the picture to the left shows there's just above the window on the right is a heat pump, and is a mini split, and that does a fine job addressing that section, which it consists of a living room and a dining room. To the right is actually a section of the house that is longer, and the heat pump is sort of further away. And this is a quick picture that I just took to give you a sense. And we actually have 3 overhead fans to push the heat down so that it makes its way across the entire length of the house. And it seems to work very nicely. We've had very even heating, you know, and I know it hasn't gotten that cold, but putting those fans, those overhead fans, I think are helping. And maybe Chris, you'd have other suggestions on how to do that, but you definitely can sense that you get a balanced heating from the heat pumps. I guess, yeah, Phyllis, and I can just, you know, this is something, the carbon footprint, the energy usage is important. So you can click on the next slide, I guess.
Sorry.
Oh,
I was too quick.
folks that I've been tracking it, and it's not.
Sorry, I lost it.
Yeah. Oh, no.
It's here. I have too many things open.
Yeah, well, it's just a couple of charts to just see how we're doing.
Okay, yeah. Okay, give me 1 sec. I can do it now.
Oh, okay.
Can you tell I haven't zoomed in
Maybe you're zoomed out.
Maybe
Just
that's
keep
really
breathing. Just keep breathing. And that's my philosophy when I'm doing this.
it.
Just keep breathing.
You're fine. Yeah. Because you get overly stressed. You get overly stressed when
Here
you're
we go. It's
there.
here.
You go. Yeah.
All right,
Like
brilliant. Well
my
done.
people, I can't be too stressed.
Yeah. We're all amongst friends.
Yes.
Yes.
At any rate, this is just, you know, and these particular charts are really to show the a comparison between 20 and 21 electric and heating use. And the top chart is gas plus electricity, and you can, you know, gas is usually reported in therms or BTUs, and I just converted that to kilowatt hours. And the lower chart, it represents just what we use in electricity. And the scales are kept the same just to show the impact of how much, you know, you use in gas, one may use in gas in terms of energy in this type of climate. And we do have a gas dryer. You know, when the solar thermal isn't working, the water is gas heated, and gas stove and the furnace. So, you know, the fair amount of large items do use gas. But the bottom chart shows how much electricity that we're using in comparison, sort of separated out. And you can see that the bars that are to the right, that the furthest bar to the right shows what we used in 2020. The next bar shows what we consumed in 2021, and the blue bar shows what we consumed after we took advantage of or basically what we net metered after using the photovoltaics. So, you know, in essence, and the next chart just shows sort of what we've been doing on our carbon footprint. And you can see that, you know, we've made a pretty decent dent in it, in our carbon footprint. And really the goal is to really, I mean, the goal is obviously to get to net zero, and then at some point in time, you know, zero carbon 24/7 a day. But that's a stretch objective. But anyway, this sort of gives an idea of how the heat pumps play a role as we start working on the second floor of the house. We plan to put in another heat pump that should make a big difference as well. And there's a set of other efficiency measures that we have in the works that should get us there. So yeah, that's the complete picture.
Thank you.
From our
Thank
house.
you.
Yeah.
Next, I think I'd like to have Janice, if she has a minute or two to share her experience or her son's experience. Are you there, Janice? Are you on mute? Okay, how about Susan? Susan, do you have a second to share your perspective? Thanks.
Yeah. You're welcome. So my name is Susan Bevilacqua. I'm a real estate agent for Pinnacle, and I am selling the properties. I'm sure many of you have driven by it and heard about it at Fieldstone Way off 135 going into Needham in Wellesley. It's in Wellesley going toward just before the Needham border. So we have 44 units that are being built there currently. We have sold 33 of the 44 units, where we should be completely finished with it at the end of 2022. Those units have none of the units there have gas from the street at all. We are completely a heat pump property. So, and I'm very proud to say that everybody's very happy and very pleased with the heat pump systems. We do have, Chris, it was actually really great to hear your presentation, because it was very helpful actually to me. I thought I knew a lot, but you helped me learn a little bit more. But so we have 3 zones in each of the properties. So we have the larger systems for the first and second floors of the property. And then we have a mini split system for all the lower levels in the property, but they are all heat pump fueled systems. Everybody has been extremely pleased. And again, we've sold 33. So those are people, we have a majority of people living in those properties for about a year. And everybody's very pleased with the systems and their efficiency and so on and so forth. So I think and I will say this from a sales perspective, when people come in and I say there's no gas from the street, this is an electric, system, people are slightly horrified, to be very blunt. At first, they're like, what? Like, it's just electric. And then I explain and it goes away like that. And I explain that this is the new wave and, we're really trying to reduce the carbon footprint and so on and so forth. And people respect that. And we've had really, really positive feedback from everybody on site. So I think this is a great, I hope that it continues in the town. So
Thank you.
You're welcome.
Janice, are you there now? Do you want
I
to?
am.
Okay,
I am
great.
here.
I'd love to hear a little bit about I know that your son has it and
Okay, so my son built a home in Wellesley in 2015, and I was calling them mini splits, but everybody now calls them heat pumps. So when he built the home and I took a tour of the home, there was no furnace, there was no boiler. There was just 1 heat pump on the first floor and 2 heat pumps on the second floor. And I've been in and out of his house now for the past 6 years, and it's always at a comfort level. So last summer, being tired of it being hot, and we didn't want to use, we had a very old AC unit that we put up into our living room. We decided that we would make a transition, but we were only interested in doing that for cooling, because we have a very high energy efficient gas boiler. And so we had heat pumps installed last December. We never turned them on. they told us we could use them in the sort of the shoulder season and even in the winter time, but we bought them specifically for cooling. So we turned them on for the first time last summer, and they were wonderful. They are so quiet. You don't hear anything. You can, if you want to, put a blower on and then you hear a blowing noise, but we chose not to do that. And for people who don't have heat pumps, the remote is very complicated. You have a lot of different choices that you can make for, yes, mine is even more complicated than that one. So it was wonderful this summer. I was just basically tracking how much electricity it was using, and it was hardly using any electricity at all compared to past summers. I mean, I think we paid $2 or $3 more throughout the summer for electricity. So when fall came, I remembered that they told us that the shoulder season is the perfect time to use a heat pump. And what we were doing is we were turning it on in days that it was getting cool in the afternoon, and then we were turning it off in the evening, and we were turning it on. And then finally we decided as it got to November that we should turn it on and really try to use this as a heat source. I was fiddling with the remote. I was trying to get the right combination. I could not figure it out, but then MLP one day sent out an email that there was going to be a webinar that evening, and I listened to the webinar. And Chris, you at the end of that webinar, you gave it was a little QR code, but then it gave you what you need to do with a heat pump, and basically it said turn it on, leave it on. Don't fiddle around with it. If you have a backup system, your backup system might turn on at some point in time. So when I followed what was on that, it worked out perfectly. So right now we are heating with our heat pump. This morning it was 17 degrees when we got up, and the house was very nice and warm. It's totally quiet. There's no noise at all. Every now and then in late evening when I'm lying in bed, I can hear a little bit of a hum. But other than that, I don't hear any noise from it. So I think it's a great product. And, you know, I chose it because I wanted to put in some kind of a cooling system, but it works very well with the heating system. And also the other thing is we are reducing our carbon emissions, which is really important.
Thank you, Janice. So Mary Gard, is there anything else we want to say before we open up to Q&A? Or should we just open it up? Because I'm sure folks have some questions for our people here. All right, Mary, you're on mute. So unless you want me to.
All right, yeah. So I'm going to drop that webinar that Janice just talked about, because I think it's the most important and most illuminating webinar out there on how to use your heat pump. And so I'm going to put that in the chat. Also, I wanted to say that concerning Monier's issues with the setback, the planning board tonight is meeting to revise their bylaws so that they can eliminate the obstacles to, after a little bit of pushing. They might not get there, but we have a citizens petition that we're ready to go forward with in case planning can't do it. Because the fact is that heat pumps are quieter than the old standard air conditioning that the bylaw was about. So that's one thing. I also wanted to say that those of you who are considering air source heat pumps, the state Mass Save, which is sponsored by the big the big utility companies like National Grid or Eversource, they have a 3-year plan. Every 3 years, they update their rebates. And they just 2 days ago came out with a new plan, which will subsidize even more generous rebates than Wellesley has. So if you're thinking about heat pumps, this is my advice. And I know this is not probably what you would expect, but I would say update your house, make sure that your house is sealed and insulated, go through Mass Save or go through the MLP if you're oil heated, and then wait a few months, because they are, the Mass Save program is going to throw $8 million toward heat pump subsidies. So I think it makes sense for anyone listening to get your house ready and make sure it's airtight, and then apply for these new subsidies and rebates, because it's going to be very generous. Unless you feel like your furnace is going to go, and then in which case you should go ahead and apply for the MLP rebates. But the state, because of the recent bill passed by the state, the whole state's moving toward net zero. And so they're trying to help people finance that. So that's all.
Great.
Yeah.
Tom had his hand up first. I'm going to, Tom, why don't you unmute and ask your question or share your comment, please?
Well, first I want to thank you guys, everybody for what you've done, the organization and in the presentations. I'm an engineer and we live over over here in the precinct D, and we wanted to several years ago. I've been exploring changes before it was big on the footprint, on the climate, and we have a boiler system, hot water, heat. And we wanted to put a heat pump in, and of course we ran into the first problem was the plot plan, which was going to. Then by the time we costed it out, it was going to cost about $22,000 to put the units in, because we would have to bump from our 100 amp service to 200 amp service, which also would include digging up the road in front of our house and then putting in a unit underneath to go to 200 amp. And then the cost of the heat pump, the cost of the plot plan brought it up to about $22,000, with the rebate would be about 20. But our total utilities, everything, natural gas, electricity, sewer, water, is like $3,400 a year. So it's like, okay, so where's the savings? It might take 40 years to get a payback. So there's a flip side to the issue that everybody has to consider. And of course, it would help if we didn't have to do a plot plan, which was fairly expensive. On the other hand, I was glad to hear from the realtor person just a few moments ago. I forgot her first name. We need to get those things into. There's been a lot in the last 6 years, even a lot of new construction around Wellesley, and I'm not sure how much has had heat pumps in. Is Wellesley pushing that when people put in a building permit for a new home, that are highly recommending putting in the heat pumps? Otherwise, trying to convert somebody else's house like ours, if we sold, moved out, and a contractor bought it, ripped our house down, started again, which they do in a lot of areas, yeah, then the heat pump would make sense. But anyway, I just thought I'd point that out, and I appreciate everything you guys are doing. Thank you.
I can speak to that, Phyllis, if you want.
Yeah, great.
Yeah, so the planning board tonight is discussing the setback issue, but also they are going to start including sustainable guidelines when they consider projects of significant impact. And also the design review board will be throwing sustainability at specifically greenhouse gases when they review projects. But the problem is that we can't require having building standards include energy efficiency, because the state bylaws are overseeding ours, and so we can't be any more stringent in our building codes than the state building codes. So the next step is the state right now is considering a net zero building code, and green communities, which is Wellesley is a green community. They can opt into this net zero standard for new construction. So I think that happens in sometime in the next few months. The state will decide what they're doing with building codes, and then we can opt into that. But we can't, as a town, we can't be any more stringent than the state's codes. I don't know if that makes sense, but
Thank you.
yeah.
Yeah, I'm not sure, Mary, that, I mean, I know that Somerville is introducing their own.
Yeah. So cities can do it, towns can't.
Oh, got it.
Yeah.
Okay. I do know that there is a very strong push on the legislature to get to a net zero building code as you
Right.
described.
Well, and
Yeah.
you know, Brookline had a policy in place. This is Susan, the realtor. But Brookline had a policy in place where any new build had to be electric. But they found a loophole. And so that's not the case anymore. But it's starting to happen. And my opinion, selling these properties is it's really just about educating people. The minute I start talking about it and explain it, people are fine. And and these are like, you know, educated people that are buying these properties, and everybody's used to gas. The minute I'm like, okay, it operates just like it's a forced air system, so on and so forth. Here are the handlers. It looks just like your handler, you know, people are like, oh, cool. Okay. And it's over. And I think that's the basis so this is why this is great, what we're doing right now. And so I hope the Fieldstone Way project helps that. But in any case, that's my opinion on, you know, just educating people, right?
Yeah. Susan,
Go ahead.
I was just going to say, Susan, if you want to convince people about natural gas in the household, you can point them to a study in Phoenix.
Yeah.
Where they compared the health and well-being of residents between people who lived in a all-electric home versus gas, and there's a very clear measure of early onset Alzheimer's.
Oh God. Okay. Yeah.
Amongst those who live, and if you think about it,
Yeah.
it generates a lot of carbon monoxide when you fire up the gas that you're breathing in, and that's the consequence of it. So it's it's
And
not
asthma too. I think there's a lot of
an asthma. Yeah.
I didn't
Yeah, I
know
mean-
about the Alzheimer's, but that's a compelling case. I mean,
I would say.
yeah, and something that I talked to Mary about before this is, I remember we had a house in Maine growing up, and my dad used to complain about electric heat, because it took so long for the house to warm up and it was so expensive. So that is one of the first things I say to people, because the people, predominantly the demographic people buying into Fieldstone, are 55 plus. And I'm trying to explain to them, I'm like, it's not like what we experienced in our childhood. This is exactly the opposite. I mean, it's more efficient. It's better for this, that, and the other. And everybody kind of laughs because we all remember the old baseboards that took forever, that turned red and, so on, and they smelled, remember, like to heat them up. So it's just, again, I don't mean to keep repeating, but it's all about just educating people on how far we've come, right? So, but the Alzheimer, I'm going to use that one. Thank you.
maybe when you're
Susan, I'm so glad you're here, Susan, because that's the kind of disinformation that is slowing this transformation down. And it's true. So thank you. I'm so glad that you're talking about this. I appreciate it.
There's one question on the chat that says, Michelle asked about, and maybe Chris could answer this, or Munir, I don't know if you have experience, but can you get rid of your gas boiler if you go to heat pumps? And do you have to keep Do you have to keep that for the hot water heater? Chris, are you still there?
Out there, and I think
Up to you, really. You don't necessarily have to keep your boiler around just for the hot water. So if you want to go and get rid of all your gas, you can just get a heat pump hot water heater, or you could get a solar thermal like Meneer has, and you can mix solar thermal with a variety of other technologies, such as just an electric hot water heater backup, or even a heat pump hot water heater. So there's a lot of options out there when it comes to domestic hot water. So short answer, no, you don't have to keep your gas. You can get something else.
Great. So it's coming up to 8, which we promised to stop at. Is there anyone else who has one more question or comment before we say goodnight?
I want to clarify one thing with the upcoming mass save rebates. So for folks in town that still have oil, propane, et cetera, like delivered fuels, you will not have access to those new mass save incentives. It's only folks in town that have like National Grid gas. Those folks will have access to those mass save incentives. That is still needs to be approved by the Department of Public Utilities, and we won't know what their answer is until sometime in January. But if it does get approved, the rebates are huge. So it would be amazing for folks to be able to take advantage of that. It seems very likely that those are going to get approved. I don't know how WMLP what route they'll take as far as who has access to what rebates. I don't think the incentive program will go away because there's still folks with oil and propane and such that need access to rebates and incentives. I don't know if they'll be able to double dip or not. Maybe a little bit of a philosophical question for WMLP to think about, but yeah, if you have any questions on that, I'm happy to ask, but just wanted to clarify that little.
Thank you, Chris.
Yeah.
Lucy, your hand's up. Go for it. We'd love to hear from you.
Hi, it's Lucy and Phil Saunders. We have oil burner forced hot water. Can we utilize that distribution system with a heat pump? I recognize that it probably wouldn't work, heat it up enough to work in 20-degree weather, but could we use it combined with the furnace as kind of a base load heating?
Potentially. I haven't seen that configuration myself. So there is a lot of hot water baseboard around in our area, or radiators and things like that. Contractors actually call this area like, I think it's called like Boiler Alley or something like that. It's a very unique area in the United States where there's all these boilers around. There is heat pump technology that should be emerging maybe this coming year. That should be able to heat the hot water up to a higher temperature, and it may be more realistic for folks to reuse their existing hot water baseboard or radiators. The trouble, like you're saying, is that the heat pumps, they only heat the hot water up to right now around 120 degrees, which is great for radiant floor heating and things like that, but reusing existing baseboard as it is, it doesn't have enough surface area on it to get enough heat out of it to keep your house warm, like you were saying, like when it gets cold, like 20 degrees or lower. So short answer, not yet, I guess. Hopefully soon we'll have technology that can do that, and kind of the 1-for-1 dropped out, take out your boiler, put in a heat pump that heats up the water in your baseboards. Still kind of to be determined. I haven't got my hands on any of the technical data to really know exactly what this technology is capable of yet, but they're testing it. I've been hearing, from different people who are involved that it's been working great, but everything's hush hush and they're not releasing any data yet. So I'm excited. We'll see what happens. But yeah, in a situation like yours, you could kind of wait and see if your boiler's not, end of life, or you could consider the existing technology that's market ready right now.
Thank you very much. Thank you for your presentation, and thank you for telling me that I live in Boiler Alley.
I have a question.
We all do.
Sure.
Hi, may I ask a question?
Absolutely. Hi.
Hi. I'm actually Liz Grossman. I live in Wellesley, and we have hydro air system by gas, which was pretty much ahead of its time 30 years ago. But we're up for a new heater. And my plumber was here, who's terrific. He actually works with Boston Gas and does things on the side and helps us out. And he did mention to me that if we went to if we changed the system to one of these new modern systems, we would still have to maintain a backup traditional system when it's very hot and very cold, you know, for the air conditioning and for the heating. Is that true? By the way, my house is 3,800 square feet. So you get a sense of the house. I have 3 zones. And he was pushing actually a new gas heater, which he said will be the size of a large suitcase. And he said, you'll be amazed at how inexpensive, and it would still be hydro-air. I mean, you didn't address hydro-air at all. So I just wondered what you thought about that. Now, maybe this is addressing Chris. I'm not sure. Thank you.
Thank you, Liz.
All right, I'm doing my best to answer questions in the chat and at the same time try to listen to folks. I'm sorry if I missed a tiny bit of your question, but I think I got it all. So with hydro-air systems, if you have like an existing system like that and you have air handlers around the house and then you have a boiler that's sending the hot water to those air handlers, you can, in many cases, also stick a coil in there that connects up to a heat pump. So you can have a air handler that has 2 coils in it, one for your hydro-air and one for your heat pump. Because right now, a lot of times you have one for your hydro-air and then you have just a regular central AC coil in there. You can take that out, you can put a heat pump one in instead, and that can act as your primary source of heat, and the hydro-air becomes backup or emergency, or you can have it be more of a dual fuel system where you swap over to the gas when the heat pump can't keep up, or it's more economical to swap to the gas. So does that answer your question?
I guess so. So there is a problem if it goes below 15 degrees, if it goes below 0, that we do need a backup. You don't think the heat pumps could handle it? Is that what you're saying?
Can I just say this? I don't mean, Chris, I don't mean to interrupt you, but like at Fieldstone Way, there's no gas on site. It is heat pump, cooling, heating. Like that's it. So there's no backup and it works.
But there hasn't been since that, I know what you're talking about, that area opened up. Last year was a very warm year. We haven't hit.
But there will be no gas ever on the site. Like, so.
I understand that, but in terms of experience, I just don't think we've hit a really hard year. Last year we were lucky. There was no snow. There was, it rained most of the time. So I don't know if they've ever lived through a year where it goes, below 5 degrees. I really don't think so. Certainly not last year.
But my point is it probably will go below 5 degrees and there's no backup gas system and it will function.
I'm hopeful, absolutely, but you don't have the experience. That's what I'm trying to say. Nobody's actually lived through it yet, unless I'm wrong, correct me. So, that's my concern. That's all. I think this is all fabulous doing, moving into these new type of heating units. And I'm really very seriously considering doing it. I think I should ask one more question. Christopher, do you know how much it would cost to come into a home that's 3,800 square feet that has 3 zones to switch it all around? And do I have to, one of the reasons I was hesitant to go for a heat pump initially is they used to have these big units over the doorways or on the wall. And I can see one in Phyllis's house behind you. It works in your house, but it really wouldn't work in mine in terms of look. So I love the fact that they've got new vents that are in the middle of the ceiling or maybe, I don't want to put a radiator kind of thing in either. How do you get it into the middle of the ceiling? You have to open up the whole ceiling to get it there. So it's a lot of construction.
All right, so a few questions to answer. So I first want to address the concern about cold temperatures. So the technology is totally capable of providing all the heat that you'll ever need in our climate, no problem. One of the states that has the fastest rate of adoption of homes converting to heat pumps is Maine. If they can do it, we can too. And then as looking worldwide, Scandinavia, it is the #1 heating system, heat pumps. So everyone's switching over to doing that over there. That's much colder, much more north than Massachusetts. They experience much more terrible winters than we do. So they can do it. We certainly can too. As far as like designing your system, you have to make sure that, for one, your house is, insulated and sealed up. You can design a heat pump system to heat a leaky farmhouse, but it's not going to be efficient. It's going to be wildly expensive because that's not what they're made to do. They're made to heat homes that have been insulated and they're tightened up. You can still do that in, you know, older homes, no problem. You can have Mass Save come out, or you can have Energy New England come out, get the direction that you need to get your house weatherized. And then you can look at doing heat pumps, just to make sure that it's cost effective, they operate well and everything, and perform well in your home. So looking at like a home like yours, Liz, you have like the ducted systems. Retrofitting into existing homes is definitely different than like a new build, like was what Susan's experiencing. New builds, building code is fantastic, and so those homes require much less heating and cooling than like an existing home does. So it's just a different scenario. Each one is doable. You just approach it different ways. With like an existing home, you have like existing ductwork, and depending on the age of that ductwork, it's going to be potentially designed not the same way we would design it today. I'll put it that way, right? And so the sizing of it, things like that, it may not exactly pair well with, you know, new state-of-the-art heat pump technology. So it's going to be case by case, but having contractors look at your ductwork, seeing the sizing of it, and if it will match well with a heat pump, things like that are all considerations. That's to see if it's, you know, viable for you to transition your ductwork over to something that you could do 100% heat pumps with. And then there's the weatherization aspect of it as well. So to do like you said like a 100 square foot house with 3 ducted systems, was that correct?
3,800. Yeah,
Yep.
that's correct.
So you can get quotes that could be like way over here and way over here. So it's going to depend on the shop you're looking at, the brand of equipment you're looking at, and the type of heat pump you're looking at too. So there's kind of like 2 types of heat pumps out there. There's like standard heat pumps, and then I would call them cold climate heat pumps. So standard heat pumps are equipment that is more so designed to operate in a dual fuel setup, where you will plan to use something else when it gets really cold outside, such as gas. Just because standard heat pumps, they do lose heating capacity when it gets really cold outside. So by the time it gets down to 5 degrees, a standard heat pump may only have 60% of its total heating capacity. Not the great kind of heat pump you want to rely on as your sole source of heat, right? But that's not what they're designed to do. They're designed to be paired with something else. Those type of heat pumps, you could use them as your sole source of heat in the Midwest or the South, but not up here. Then there's cold climate heat pumps. Those have 90 to 100% of their total heating capacity at 5 degrees, and they can continue to operate well below 0. They still maintain the heating capacity quite well. So you can rely on them. If it gets super cold, we have a night where it's, you know, 0 degrees for a few hours, or it's even -5 for an hour or 2. We see that weather from time to time. These things will keep chugging along, keeping the house warm, no problem. So picking what type of heat pump makes sense for you when it comes to like your ducted systems. Sometimes retrofitting existing ductwork if it's sized inappropriately, because in the past we oversize stuff all the time. So if somebody figured out that you didn't need as big of a system in reality anymore, maybe that ductwork wouldn't be really sized super well for a brand new heat pump. So it's case by case, and some of this can get really technical, as we're seeing right now, really quickly, and that's what we're here to help you with. So you can set up chats with us and talk through all this stuff and help you understand the jargon and what makes sense for your home, stuff to ask contractors, all of that. So it gets technical quickly. I'm sure Munir experienced that when he was looking at all the different options he could have done for his home. So that's what we're here to do. We're here to help.
Thank you very much.
Yeah,
Appreciate
sorry for the long-winded answer. So everybody, I went way past 8 o'clock.
It was excellent, actually. Terrific. Thank you.
So for all of you that want personalized service like Liz just got, you can go, if you go on the Sustainable Wellesley website under news, there's 2 articles about tonight, which probably brought you to this event, but in there are the links to, you'll be able to get in touch with Chris and his team. And if you have any other questions, you can call the light plant, and, worst case scenario, call us or email us at info@sustainablewellesley, and we'll send you in the right direction. But thank you, Chris. Thank you, Susan, Munir, everyone, for your great questions, and Janice for sharing your insight, and have a lovely evening.